Lab 10, Percent Composition of Hydrates. You are a research chemist working for a company that is developing a new chemical moisture absorber and indicator. The company plans to seal the moisture absorber into a transparent porous pouch and attach it to the cellophane window on the inside packages for compact disc players. Wait, what? CDs? Perhaps your company has also invented time travel. Anyway, the moisture within the packages will be absorbed, and any package that has too much moisture can be quickly detected and dried out. Your company's efforts have focused on copper 2 sulfate, CuSO4, which can absorb water to become a hydrate that shows a distinctive color change. When many ionic compounds are crystallized from a water solution, they include individual water molecules as part of their crystalline structure. If the substances are heated, this water of crystallization may be driven off and leave behind the pure anhydrous form of the compound. Because of the law of multiple proportions also applies to crystalline hydrates, the number of molecules of water driven off per mole of anhydrous compound should be a simple whole number ratio. You can use this information to help determine the formula of the hydrate. To help your company decide whether CuSO4 is the right substance for the moisture absorber and indicator, you will need to examine the hydrated and anhydrous forms of the compound and determine the following: the empirical formula of the hydrate, including its water of crystallization, if the compound is useful as an indicator when it changes from hydrated to anhydrous form, and the mass of water absorbed by the 25 grams of anhydrous compound the company proposes to use. Even if you can guess what the formula for the hydrate should be, carefully perform this lab so that you know how well your company's supply of CuSO4 absorbs the moisture. Remember your lab safety precautions. Heating the empty crucible and lid.
So you guys should be watching, and when it turns slightly red on the bottom, that's what we're looking for. It'll start to glow.
Drying the crucibles in the desiccator.
Put this on or just...
Yeah, put it tipped a little. Perfect.
Determining the mass of the empty crucible and lid.
It won't burn the counter because the counter's granite. Not yours, not yours. Okay. Coming around. Okay, well, work on it till I get there. I'm almost there. Go. Good deal.
Add 5 grams of copper 2 sulfate to the crucible. Determine the mass of the crucible, lid, and copper 2 sulfate sample. Heating the crucible, lid, and sample.
Good so far. Get the video over. You can increase your flame a little if you want. You're about at that point.
Return the crucible and sample to the desiccator.
Beautiful. I'll put all the lids on when I get over here. Sorry.
Wait, which one's mine?
Your B.
So I'll tell them now.
Determine the mass of the crucible, lid, and sample. Heating the crucible, lid, and sample for a second time.
Half of those are so. I'm not done yet. Wonder what's your rabbit road.
Return the crucible and sample to the desiccator for a second time. Determine the mass of the crucible, lid, and sample. Set aside and rehydrate a portion of your sample.
It's broken.
All you need is a drop.
Okay.
Is that a hole in it?
Awesome. Nothing.
There you go.
Whoa!
Nice.
Jello.
There you go. That's fine.
A masterpiece.
There you go. Here's your water. Got it?
Yes, ma'am.
That's
so dope. Weekend, look.
Very cool. Chunky in there. It's fine. You can grab the whole thing or grab a piece of it.
Is that hot
So the bottom of it turned yellow. Yeah, it's still hot.
I'm
You know what? Use this and pour it. Yep. There you go.
All right, who wants to do the honors?
Go for it, Seb. You doing it? You doing it, Cole? Who's doing it?
Alex, you want to do it? Just lightly tap a little more water in there with this.
Just squirt the water on it gently.
Gently, yeah. Oh, cool.
Nice. Good job. It's still warm, yep.
What did you observe?
Bright blue.
The water turned blue or the crystals?
The water and the crystals.
Water and the crystals?
I was gonna say the water turned to substance, which is crystals.
There you go. Okay, good deal.
Clean up your lab. Why was it important to have very clean equipment? For example, the crucibles and tongs for this lab.
You need to keep everything clean because for it to be, if it was dirty, then it would have other stuff on it, other objects on it that would weigh more or weigh less based on what was on it, and that would change your final result. Because if it was dirty halfway through but not at the beginning, it would give a different result. That doesn't need to.
Why did you cover your crucible when determining the mass?
She just erased it all, that's why.
So the formula doesn't matter, I think.
Why are we doing that?
So the steam can escape.
So the gases and stuff can escape. Right, perfect. Good answer, good answer, good answer.
Calculate the mass and moles of the anhydrous copper 2 sulfate.
I don't have the molar mass. I have it's 159.609 grams per mole of just the formula by itself.
Okay. All right, that's good, that's
I
good.
didn't get the.
Calculate the mass and moles of the water originally present in the hydrate.
Grams of water.
Wait, what did you get, Abby? You look like you're going to answer.
We had 2.3 grams.
You had
of water.
2.3 grams of water. What did anybody else have?
Explain the reduction in the mass of the sample after heating in terms of the law of conservation of mass.
Getting there a little bit. Getting there. What was? Okay, you have something to add, Alex?
The water evaporated.
The water evaporated. The water where? What was it part of?
The water in the substance evaporated.
There you go. Yeah, there's water that's part of the crystalline structure, and we evaporated it. So we didn't lose mass, did we? No. Where did it go?
It just went into the air. It was ejected.
Can you determine the empirical formula for copper 2 sulfate? What's the percentage by mass of water in the original hydrate?
0.3 grams of water.
With what percent?
It was 40% of 5.
Did anybody else get that yet? Did anybody get that far yet with their calculations?
What will you report to your boss? Will this substance make a good moisture indicator?